Okay, so in this video we're going to be looking at the sine law, more of a refresher. Sine A over A is equal to sine B over B, or even inversely. Where the lowercase a and b represent the length of a side, and the uppercase represents the angle. So say we have a problem like such, where we have C, A, and B, where B is 7.8 meters, A is 5.9 meters, and this angle is 36 degrees. And now I want to find out the angle of B. So, let's start plugging in some numbers. Remember, this is a refresher, so you should know how to do this by now. If not, you can go back into previous or old videos, and I have it explained in those ones. So let's do 5.9, and over its opposite angle, sine 36 degrees is equal to 7.8 over sine B. So, with a little bit of rearranging, I'm going to bring the sine B up to that side. Multiply this sine 36 up that way, and bring that 5.9 down here. And I'm left with this. Yeah. So my B is equal to the inverse sine of 7.8 times sine 36 over 5.9. And if I punch that into a calculator, I should get 51 degrees. And now, with my triangle law, I know that 36 plus 51 plus C will give me 180. So I can subtract 36 and 51 from 180 to get 93 degrees for C. And there you have it. And now, with that angle, I could just simply punch in the same 5.9 sine 36 is equal to sine 93 that I got. That's that one over C. So now C is going to be 5.9 sine 93 over sine 36. Punch that into a calculator, and I got about 10 meters. Remember, I have meters in my units always. So, yeah, math is really definitely fun. So, let's look at another example of another triangle. Let's do one with a bigger angle. Let's say this angle is 140, and I have this 15.6 meters here and 36 meters here. So, let's say that this is an imaginary axis, and I want to find out the angle here. How am I going to do so? And let's say this line here is going to be parallel to the ground. I forget how to spell. Anyways, so let's try to find this angle. And from our angle laws, we know that when you have a C shape, this angle is the same as that angle. So actually, I want to find this angle. And now it just comes back down to a silly sine law equation. So if we start punching these numbers again, we have this sine theta is equal sine theta over its opposite length 15.6 is equal to sine 140 over my 36. So if I multiply both sides by the 15.6, this will cancel out and I'm left with sine theta equals 15.6 times sine 140 over 36. And yeah, if I start punching this into the calculator and take its inverse theta, then I should get about 16 degrees, or 16.1 or 2. But basically, once I found this angle, I can say that that is equal to this angle. And there you go. That is a quick refresher of the sine law. I think next we're going to be looking at the cosine law. Just as a refresher for, actually, you know what? Why split it into two videos? Let's just dive into it. And if you remember the cosine law, yeah, it should have been, if I'm looking for, let me do this in a different light of color. Let's do this one. I have a squared equals b squared plus, I need more space. And as well as yeah, that should basically be it, because if I have any triangle, so if I have these two that I'm looking for, well, basically cosine law, if I have the three sides and I'm looking for one angle or any angle, I'm looking for an angle, I can use this. If I have A, B, and C, similarly, if I have, say, A and, well, let's say I have C and B, and I have the angle in between. If I have cosine law to find things. So let's actually try this out. Just a quick example. Let's do 55, 32, and 26. And now I want to find, let's say I want to find this angle. Let's call it cos A, because that's what I'm going to be plugging in here. That'll be my A. So let's punch these in. So 55 squared. Let me write it here. 55 squared is equal to 26 squared plus 32 squared minus 2 times 26 times 32 times cos of A, which I don't know yet. So I can start bringing these over and subtracting them. So that'll give me 55 squared minus 26 squared minus 32 squared. And on this side, if I'm left with this term only, I want to get rid of all that and just isolate the cos A. That's all being multiplied by all this, so I can divide it. So now I'm left with this, and all I really have to do now is take the inverse cos of that, and I'll get the angle A. So if I punch all this into a calculator and get a number and do the inverse cos of that number, I should get an angle of about 143 degrees. And that is a example of us using the cosine law when we have 3 sides and we want an angle. But if we have, say, another example, say like this. Say I have 10.6, 22.9, and I want to find out the side B. And I have this angle 26. I have the angle and the 2 sides to it. Let's pretend this is straight. Okay, now I can use the cosine law again, where in this case, this will be technically my A, because I have the opposing angle. So technically this is going to be, I can even call this A, just so I don't confuse anybody. So I'm going to have A squared is equal to the 2 sides, B and C, 10.6 squared plus 22.9 squared minus 2 times 10.6 times 22.9 times cos of 26 degrees. Oh no. Let me write it back here. A squared equals 10.6 squared plus 22.9 squared minus 2 times 10.6 times 22.9 cos 26 degrees. Now all you have to do is solve for this. And if you just punch all that into a calculator, you get 200.42. And that's A squared. But A is going to be the square root of that, so you're going to get 14.16. And that's the example of us using this. If we have an angle and the sides on each of it. So yeah, that has been us using the cosine law, we can actually do one example where we use both the cosine and sine laws. So look at it like this. Say I have this triangle and I have angle A 60 degrees, but B, so that's capital B. I have this theta here, and I have C, which is also equal to 5.1, and this is equal to 8 meters. Now, say I wanted to solve for this angle. So right now, I cannot use the sine law because sine law requires me to have at least one angle and its opposite length to be able to do the other calculation. So I have this and that. So I could do sine theta over 5.1, but I don't have anything to compare to. I don't have 60 and B, I don't have A and 8. So I can solve for one of them. And let's try solving for B in this case. So I'm going to solve for B because remember my cosine law where I have the angle and the two sides. I can find out the opposite length. So I have this angle and measurements for the two sides. So let's punch that in. I got B squared is equal, because that's B. And I have the other two, A squared plus C squared minus 2AC cos B. So if I was to plug this in, I would get B squared is equal to 5.1 squared plus 8 squared minus 2 times 5.1 times 8 times cos 60. Sorry. And if I was to solve for this, I should get about 49.21, and B will be equal to the square root of 49.21, which is about 7 point something small. But I'll use 7 for now. So that's equal to 7. Now I have my sine 60 over 7. Now I can use the sine law and just solve for that. So my sine theta is equal to 5.1 sine 60 over 7. And my theta is equal to the inverse sine 5.1 times sine 60 over 7. Punch this into a calculator and you will get theta is equal to 39 degrees. And there you have it. And you could even add this to 60. 180 minus 99 should give you 81 degrees. That's going to be this. Using the logic that the angles will add up to 180. So yeah, that has been cosine law and everything, the sine law. Just a refresher. So I hope that was a good refresher, and we'll see you back here in the next video to do something more confusing. And that's all for this one. So see you in the next one.